Hi,
Hi.
Fabrizio.
Hi, Laura. How you doing?
I'm very good, thank you. Good to see you here, and
Good to see you
welcome
too.
to our series of Back to the Future.
Thank you for inviting us. It's really nice to be here.
So we're going to dive into phenotyping and indoor farming, diagnostics, forecasting. So a really exciting topic. But let's first start off with Gardin. What do you do at Gardin, and what do you help your clients with?
So we are a monitoring company and an insights company. So we develop optical sensors that can monitor your crops, and our sensors are designed to measure plants at a range without the need to touch them or destroy them. They can cover quite a big area, and our kind of philosophy is to measure plant physiology, so to measure biochemical processes within the plant, things that you cannot see with your eye, such that we give people insights about how the plants are responding to the environment, to growth strategies, to treatments, and that gives them better understanding on how to run their farms efficiently. Yeah, if that makes sense.
Yeah, no, it absolutely
Yeah.
does. Um,
We work with indoor farms of any kind. So our customer base is basically greenhouse growers of high tech, mid tech, but also we work in polytunnels in
mhm.
lower tech settings, and of course we work with vertical farms quite a lot. Um, and we also have an R&D offering for research organizations like breeding companies, crop protection companies that are interested in physiological data automatically acquired for them. Yeah.
Okay, great. So quite a diverse set of clients and offerings, I guess, with it. So with all this measuring and monitoring that's going on in the industry at the moment, I thought it'd be quite interesting to take a step back 10 years ago. Could you perhaps paint us a picture of what it was like growing a crop indoors 10 years ago? What was diagnostics and monitoring like at the time, and what were the biggest challenges then?
So I think obviously as I described, our customer base is quite broad, and I think the different markets were very different 10 years ago. So if we think about vertical farming, of course, it was much less mature than it is now. So lots of farms were a lot smaller. The level of technology and integration were lower. Obviously I wasn't there 10 years ago for vertical farming, but I presume a lot of the monitoring was done manually actually in farms that were kind of testing their business model and their technology on a small scale. And so probably there wasn't as such an integrated monitoring forecasting solution, right? If we think about greenhouses and maybe breeding companies, I think a lot of the decision making was, and to an extent still is, done by farm managers, people with like deep expertise in the sector that have to use their knowledge, their time to look at the crop, make decisions that are informed by seeing them, touching the plant, exploring the farm. So using maybe a combination of that expertise and maybe manually held devices or measuring devices that are still operated by a person, right? And so there is that kind of challenge of scale and timeliness. If you imagine you have a 10-hectare farm and you have one or two agronomists that are coming in every now and again and they have to help you make decisions, right? It's a very difficult task to keep track of everything and to spot where problems occur. And so that's, I guess, is some of the challenges I imagine were there 10 years ago. Yeah.
Okay, so you've mentioned timeliness, a lot of things being done manually, issues with decision making as well. So since then, what major shifts, I think, in technology have you seen in this space, in controlled environment agriculture, that have addressed those challenges? Any specific examples, perhaps with diagnostics, forecasting, and monitoring in general?
I think if we go back to the split between, like, let's say, totally controlled agriculture, sort of vertical farms, I think there's been a lot of maturation and quite a few Obviously, quite a few businesses have gone out of business. The businesses that remain, I think, have integrated automation a lot in their operations, especially in the UK and other Northern European markets. So there we see the integration of environmental sensors, the integration of mostly computer vision-based monitoring systems to aid decision making. In the greenhouse market, I would say the change has been more drastic because 10 years ago or more, probably people relied on environmental sensors a lot less. They probably had 1 or 2 checkpoints in their maybe very big farm. Nowadays, quite a few companies provide an integrated sensing solution that focuses on monitoring temperature, humidity, and integrate that data into a climate computer, for example. There also been a proliferation of companies that use cameras to purely look at the morphology of the crops, right, to see what the growth rates are if they're making fruits and stuff like that. So I think farmers are starting to shift towards a system where they rely on real-time monitoring more. I would say the focus has still been, for the biggest part, on morphological kind of geometrical features of the canopy, and that's, I guess, where Gardin differs, because we focus on monitoring photosynthesis, so we can give them real insight on how the plant is utilizing light, how it's responding to stress, before you see it in changes to the canopy.
So I think you've mentioned plant computers and climate computers as well. I think you've with your phenotyping technology, you've helped the sector move away from perhaps the focus on the environmental, the climate, and more onto the plant and the photosynthesis, and using that as a proxy. So what do the next 10 years hold for you? What are the next boundaries, I guess, and barriers that you'd like to push within Gardin for the next 10 years?
So if maybe I'll answer this in two parts. If I think about what we're going to do with the product we already have, so obviously we developed a sensor that can monitor crops at distance, that can measure photosynthetic efficiency, and we have that deployed in several countries in the world at the moment, and we're collecting this very rich data set of plant responses, right, to a variety of environmental perturbations. And so at the moment, we help farmers basically by providing the missing feedback, right, between the plant and what they're doing. But our experience, we didn't have enough time, I guess, to build models that proactively suggest actions, right? But that will be the next step, evolution of this product. As we mature in our understanding of how the plants respond to particular things, our insights will become better at saying, maybe the cause of the decline is this or that, or you could try this action next, right, to improve your efficiency. And that's where our development is going from a conceptual point of view. And hand in hand with that is obviously our product offering will also expand. So the philosophy will remain the same, right? We like to measure things that are like biochemical processes within the plant. So the arsenal of sensors that we provide will grow in time in the next 10 years. And we must start looking at stomatal conductance or leaf temperature, or things that are very intimately connected with the way the plant responds physiologically. And by combining this source of rich information, that will make forecasting models and recommendations ever more precise, right, in aiding the growers in their decision making. Yeah.
Okay, that's really exciting. Lots of exciting projects then for you guys in the future. I guess for the last two questions, let's cast the net a little bit wider. And what do you think will be the most exciting things we'll see in control environment agriculture, from greenhouses right through to fully controlled vertical farms in the next 10 years?
Oh, wow, that's a big question. I would like to think that we will have technology like ours will help people engineer the plant responses they want, right? To be able to manipulate at will maybe the taste of crops, to tailor to specific markets or customer demands, or maybe to tailor the nutritional content of crops and optimize farm production, not just for yield, but for for things that are beneficial to the consumer. And I think there will be a big push from consumers to actually access foods that are good for their health and promote their quality of life, their longevity. And I like to think that the work we do at Gardin will enable a future where the food industry strives for that vision.
Very interesting. So a lot more tailored future, and one that moves away from yield as the king and looking at those additional aspects that are more tied in with human health, I guess.
Yeah, or at least one that gives the farmer the tools required to strike a good compromise between the two, right? And decide what they're aiming for. Yeah.
Okay. And a final question: what is your vision for agriculture of the future for 2034?
Oh, this is a good question. I think. Well, I'm hoping that something I'm excited about, right, is outdoor agriculture facing a challenge with climate change and adverse climate conditions that are quite extreme. And we've seen quite a few examples of this here in the UK, but also I'm Italian. In Italy, there's been lots of problems with tomato production, olive production, and I feel really passionate about the work we do with breeders, because we think that we are helping them to produce new varieties that are better suited to deal with these extremes. And by doing that, I think we are safeguarding the potential to grow food outdoors in ways that are innovative and sustainable, right? So I hope for an outdoor agriculture that is benefiting from great varieties, hopefully produced with the help of the garden systems. Yeah.
Fantastic. Well, something very exciting to strive towards. Thank you
Yes,
very
indeed.
much, Fabrizio, for your contribution. Very interesting, very exciting. So thank you.
Thank you for your questions. Yeah, for inviting us here. Yeah, we're very happy to be part of this network.